At the end of this video, you'll be able to solve any calculation question under the topic sound. And by the way, all calculation questions under this topic falls under these categories. The 10 questions we are going to look at tackle the whole concept. The first question: a school bell produces a sound of 150 Hz during assembly. The principal asks, how many vibrations does the bell make in 3 minutes? This is a question on frequency and vibrations. First, we write the information given. We are given the frequency as 150 Hz. So our F is 150 Hz and the time is given as 3 minutes. So our T is 3 minutes. First, we convert minutes to seconds. We know that 1 minute is equal to 60 seconds. So, how many seconds will be equal to 3 minutes? We do cross multiplication and we shall have 3 minutes multiplied by 60 seconds divided by 1 minute. Minute and minute cancels. 3 multiplied by 60, we get 180 seconds. Number of vibrations is given by F multiplied by T. Our F, which is frequency, is 150, our time is 180. Multiplying the two, we get 27,000 vibrations. Question 2. A DJ plays a tone of 400 Hz in a music studio. Find the time interval between successive compressions. We write the information given. We are given the frequency as 400 Hz and we need to get the time. Time is given by 1 over frequency. So it shall be 1 over 400 and this gives us 0.0025 seconds as the time. Question 3. A sound wave travels with a frequency of 500 Hz and a wavelength of 0.8 meters. Determine its speed. We have F given as 500 Hz and we also have the wavelength at 0.8 meters and we need the speed. Speed is given by frequency multiplied by wavelength. So that shall be 500 by 0.8 and that gives us a speed of 400 meters per second. Question 4. A referee blows a whistle producing a sound of frequency 608 Hz. If sound travels at 340 meters per second, find the wavelength. F is 608 Hz, V is 340 meters per second. We need the wavelength. Lambda, or the wavelength, is given by speed divided by frequency. And this shall be 340 over 680 or a half, and a half is the same as 0.5 meters as the wavelength. Question 5. A mechanic observes a sound wave with a wavelength of 2 meters moving at 340 meters per second. What is the frequency? Our wavelength lambda is 2 meters. Our speed v is 340 meters. We need the frequency. The frequency is given by v over lambda and that is equal to 340 divided by 2 and that gives us the frequency as 170 Hz. Let's look at question 6. A tourist shouts in a valley and hears an echo after 4 seconds. If sound speed is 340 meters per second, how far away is the cliff? The information given, we have the time as 4 seconds and we also have the speed given as 340 meters per second. So with this information, we need to get the distance d. Note that the echo time is for to and fro journey. So this means that our formula shall be v multiplied by t over 2. The 2 caters for the to and fro journey. 4 divided by 2, that is 2. 2 multiplied by 340, that gives us 680 meters as the distance. Question 7. A child drops a stone from a tower 80 meters high into water below. After how long is the splash had? Take gravity as 10 meters per second squared. We are given the height of the tower as 80 meters. We are also given the gravity as 10 meters per second squared and we need to get the value of t. There is another thing that we are given but it is hidden. We shall look at it. Now the first thing we need to get is the time taken by the stone to get to the water. So use this formula, h is equals to a half gt squared. That is the free fall formula. A half of 10 is 5. Then we shall divide through by 5 and we get t squared is equal to 16. Taking the square root on both sides, we get the value of t as 4 seconds. Remember, it is a positive value. Next, we get the time taken for the splash to be had. That is distance over speed. Our distance is actually 80 meters. Then the speed of sound in air is 340. 80 divided by 340, that gives us 0.24 seconds. To get the total time, we add these two values and we get the time for the splash to be heard as 4.24 seconds. Question 8. Two learners place their ears at the opposite end of a 200 meters steel rail while another student strikes it. Speed in air is 340 meters per second, while the speed in steel is 5100 meters per second. Find the ratio of time taken in air to time taken in steel. The first thing, we write the information given. We have the distance between the ears of the two learners as 200 meters. We also have the speed in air as 340 meters per second, and that in steel as 5100 meters per second, and we need to get the time ratio. Time is given by distance over speed. So for the first scenario, we consider the speed in air. So it shall be 200 meters divided by 340 meters per second, and we get 0.588 seconds. Then the time for the steel, it shall be 200 divided by 5100, and that gives us 0.039 seconds. So this means that our time ratio shall be 0.588 ratio 0.039. Then we divide through by the smallest value so that we can get an integer ratio. So we divide by 0.039 and we get 15 ratio 1 as the time ratio. Question 9. Humans hear sounds from 20 Hz to 20,000 Hz. Find the wavelengths corresponding to these frequencies if sound speed is 340 meters per second. We first write the information given, and the first thing we have is the minimum frequency, which is 20 Hz. We also have the maximum frequency, which is 20,000 Hz, and we have the speed as 340 meters per second. We need the wavelength, which is given by V over F. So we begin with 20 Hz, and we shall have 340 divided by 20, and that gives us 17 meters as the wavelength. Then for 20,000 Hz, it shall be 340 divided by 20,000, and that gives us the wavelength as 0.017 meters. And these are the two wavelengths for the frequencies. The last question. A machine alarm vibrates at 250 Hz for 40 seconds. How many complete vibrations occur? Our F is 250 Hz, our T is 40 seconds, and we need to get the number of vibrations, N. N shall be given by frequency multiplied by time, and our frequency is 250, our time is 40. 250 multiplied by 40, we get the number of vibrations as 10,000 vibrations. And this is how you can actually solve some of the problems on sound. Hopefully this video has been beneficial to you, and if so, then go ahead and like this video, comment, share, and don't forget to subscribe to this channel. Thank you for watching this video.